there's always a certain challenge. We had battery plates where flatness is the only criteria, or tailgates, so the trunk of a car, where also it's much more flatness related. It really comes with a specific position in the car, with a specific production process. The reason is quite different between each part. And now we have a combination of those parts. And that's why I think it's so funny that everybody asked me, do you really think we need straightening for Gigas? It's like, why should it be that much easier with this whole thing than it is with the shock tower, the cross member, the long member, all of these individual parts? Yeah.
Hello and welcome to the Gold Casting podcast. Today we have a special episode and it's again on our Gigacasting dig down every rabbit hole, and we have a very special guest. Welcome Philipp Hettich von Laubinger+Rickmann.
Thank you for digging me out of the rabbit hole in this case. Thank you very much for having me. Hi.
Yeah, we're just pleased to have you here because we think that you can shed some light on all the other things that you actually need to have besides a die casting machine for a humongous amount of money. And maybe we can understand a little bit more the complexity of this gigacasting phenomenon that we are all trying to grasp here.
So this time we start from the back end. So when the casting is basically finished and ready and it has to fit to the car, and especially fitting, I think that's your main topic.
Yes, if the car should have a certain width, it helps, definitely.
So that small detail, right?
Yeah, that small detail. It's kind of what we're dealing with a lot, yes. And how to connect it with some other parts in the car, yeah.
That's perfect. I think then it's really time for you to give us an introduction. What do you do? Why do you have an impact on the width of the car?
Well, okay, the rough introduction. I was born and raised in the southwest of Germany, in Freiburg, close to that area. Then I went to Mumbai for my diploma thesis, actually for the very German company of TÜV Süd, with a lot of umlaut. Went to engineering service and then arrived at non-destructive testing. And there I had some very nice and tough projects. Now I'm 41 years old, I'm married, have one daughter, I'm based in Frankfurt, ready to travel. And that would be the very quick about me. And then we can go into the deeper dive in technology. Yeah.
41. You're still in the growth phase. You know, it turns when you become 50. Then you're on the downslope.
No, when I was 39, I broke my leg in Korea. I stayed in hospital there and everything. So I think I had this little gap now, and let's see. I hope that with the mid 40s, I will get wiser and better again.
Yeah. So why is straightening parts such a big thing, and why now, if I might ask? Could you give us like an overview of this straightening, I guess, structural parts or maybe all parts?
Yeah, mostly focus in the structural. I would focus on that part. So we started it more than 25 years ago, actually, as a forming process. So for an aircraft wing, there was this Dornier, the German aircraft. They made the wings out of large aluminum plates, and they cut out what they didn't need. And somebody still needed to get that part into a wing shape, so some aerodynamics in there. And that's where they approached us and asked us if we can do the bending. And so this is how the business actually started for us. It was not a straightening yet. It was an initial forming process. And then we came to the structural casting part actually some years later, so in 1999. We started with the straightening. So the topic is not that new, actually, but it has been a very European, maybe a very German topic. And this is changing now. So we worked for the German OEMs. We worked for a few tier 1 suppliers in Europe. When I leased my business car, in fact, we estimated that I need 40,000 kilometers per year at least to visit our customers. Now, the reality, I think I'm below 10. Because just the focus changed. Suddenly this became a worldwide topic with the EVs, with the lightweight. Everybody went suddenly for aluminum, and people are more focused on the structural casting. So that is what mostly changed. And the topic is quite old itself. Yeah.
Interesting.
Straightening of a gigacasting, is that, here comes a Swedish stupid question, is that more difficult than straightening like a shock tower?
Each part has different challenges, I would say. So we develop every machine basically for one part and one part only. So we don't have any serial machine or a small application. It's really development from the scratch. And there are certain things that are very specific for a shock tower. So, I call it the bucket effect. If you have a bucket full of water, you press on two sides, the other sides go away. So this is something that's very tricky, for example, with the shock tower. With the long member, we're focused more on the general twist, let's say. So we call it 3D straightening because we usually do plus minus Z, plus minus Y, and then the twist around the longest axis. Because we realized that with the whole part in focus, you can probably solve some local distortions without actually approaching them themselves. You can do it with the main body, with the main structure. So there's always a certain challenge. We had battery plates where flatness is the only criteria, or tailgates, so the trunk of a car, where also it's much more flatness related. It really comes with a specific position in the car, with a specific production process. The reason is quite different between each part. And now we have a combination of those parts. And that's why I think it's so funny that everybody asked me, do you really think we need straightening for Gigas? It's like, why should it be that much easier with this whole thing than it is with the shock tower, the cross member, the long member, all of these individual parts? Yeah.
I have to dig into this, and sorry, Fabian, we go a little bit techy now. Is there a difference between aluminum silicon 10 and aluminum silicon 7? If you look at the alloy dependency, is it a dependency or is it just pour whatever you like?
You will be shocked that I have not much clue about alloys as the first thing, because for us it's simply not very relevant. So we have magnesium parts, we have steel parts, we have aluminum parts, and for sure there are differences, but it's much more about one specific part and about this what you have in front of you than about the alloy in general. With the brittle alloys, so with the non-heat treated alloys, there is for sure a significant change, because one of the big perpetrators, and I think that's the reason why everybody is questioning now about the straightening. If you skip heat treatment, you skip all the distortions, and that's, I think, the difference that people combine now with the alloy question. But the reality is, you have the distortion in casting, you have it in the cooling, in the die, or in subsequent processes like water quenching, in the ejection, handling parts. There are so many factors that have an influence that I think only the alloy itself isolated is not the key. It's like everything in casting. You cannot look at one spot because you change something in some parameter somewhere, and the whole process change will continue. Yeah. Did I answer your question at all?
Yeah, sort of. I mean, we're speaking about casting, so I mean that was a sharp answer you can get in this industry. I mean, if you really find someone who says yes, no, 0, 1, or left, right, he's probably lying.
Or someone's trying to selling you some snake oil that can solve every problem.
Yes, sure. Straightening does the same. You can use it for everything. Basically, we need an aluminum block in front of the machine, and you will get a perfect gigacasting. That's how it works. So then things would be simple.
Yeah. But you mentioned earlier that for the distortion, there are several factors like variation in certain axes and also the twisting. Yeah. As for these gigacasting, they're usually quite large and also quite heavy. Do you have all these factors of the distortion in these castings?
Well, so far there are, and again, it's casting, there are several answers. So what we realized is very often, at least with the sample parts that we received, there was a wall thickness issue. So it was not only the distortion, but many of those castings had thicker walls than they should have had in the beginning, because they just don't like the wall thickness change too much, because then you get distortion again. So, okay, let's say we have the rest. So we have the casting where in the cooling process usually something happens as a distortion. There they are basically the same. We then see ejection, which is more complex, I think. So the form filling factor and everything like that becomes also very relevant. And even if the form is filled, you need to get this part gently out without getting stuck anywhere. And I think this is a complexity that is worse than other parts that we saw. Water quenching is often the case also for these new alloys, and that is a big factor. You can skip the heat treatment and the variation that comes from the heat treatment. So the heat treatment is not the main perpetrator for distortion, but it brings a larger variation usually than you have with all the other processes. And then you might have something after the straightening, and that's the welding. So that's also something that can happen later on. And if you're able to anticipate, you can probably already connect to an offset. So you go for -2 in a certain area, then you know after welding it's correct. And all these factors stay. The heat treatment, that's a big difference, but that's not Giga, that's the alloy. So there are a lot of topics playing a role here. But from
But with
the parts
all
we
these
saw,
numbers, all those facts, and given the variations from start of a shift or end of a shift in die casting, do you use like machine learning or something to kind of train your systems, or how do you actually do it without revealing too much secrets?
No, I'm not wise enough to relieve all the secrets. So we're fine in that part. The first thing is we need to measure. We need to know what we're doing. So first of all, there's always a measuring part, and we need to measure correctly. So there's one specialty that I think is the market advantage of us, that we measure datum points. We don't locate on the datums and then we measure the rest. We measure both for being able to set up a location. That's the first very critical step. And then comes the software. It's not big AI, big data. It's not one of these trend topics. Although it's sometimes, there's a tendency to be understood that way, but it's more a simple comparison, let's say. If we break it down, we need to know, okay, we had a distortion of 2 millimeters. We overbent by 3 millimeters. What happens if we let go? And so the biggest learning in our software is to separate plastic and elastic deformation. That's the one thing. And then you can constantly compare. So the learning takes place with every part, but you don't need 5 million of them. Usually we achieve the effect, or we see a trend and adopt to it with 20, 30 parts maximum in production.
That's
we already adjusted. That's why it's not AI, because then we couldn't realize the speed. Yeah, and
I thought you were using up some 800 or something. My picture of people measuring components are people always making me confused.
No, we usually, with the pre-acceptance, we usually receive 50 parts, and those we need to set up the basic algorithm. So besides this degree of overbending that I've mentioned, you have other factors like do you start in the worst location, or do you start maybe on this overall, or do you start somewhere totally else? Do you press in the location where the distortion is the biggest, or can you achieve the effect by pressing somewhere else? So these are the things where the machine learning kicks in, and then the combination of these axes that we have. And this, again, depends extremely from machine to machine. So for the latest Giga we have now, we're talking about 30 axes, but we also have much simpler with like 3 axes in one machine or something like that.
I think there's a lot of impact on each axis working against the other, and just guessing now that there is a lot of work to get everything in line, that you don't overbend one axis, then you have 3 others compensating for that again, and then it's an infinite cycle.
Exactly. So the infinite cycle is one thing that we mentioned before with the bucket effect. So that's what usually happens in manual straightening, because then it can really be infinite. So we need to know very much what can we combine best. And yes, in the first parts that we see in production, it will happen that we destroy the effect that we did one step before. So it's not a constant process, and it's not a constant cycle time. It adjusts to this part that you have in front of you and this one part. Yeah.
I've heard about gigacasting that kind of cracks when you try to straighten them. Have you heard about those?
Well, I've heard about it from some people that unbuilt those cars and looked at them. Yes.
Do you think it's true?
That parts can crack? Yes, absolutely. If you put too much force in the wrong place, it's something that can definitely happen. I don't want to scare people off. So in all the machines that we built, we never had a crack issue. But for sure, the more brittle you are, the more is this at least theoretical risk. And if we see a risk, because it depends more on the location than on the actual force. So where do I press? When I press right next to a radius, it's not the ideal thing. But the good thing is usually distortion doesn't happen in the radius. Distortion happens where you have a lot of leverage, or where you have a loose end somewhere, and there you can also play much more with the distances. But it's alloy, it's geometry, it's a million other factors again that provide this risk. So if we see it, let's say in theory, then it's not equal over the whole part, so it depends on the location. So we need to compare, where do we want to press, where do we think distortion will happen, and this is a discussion with the customer, because I'm not a casting expert, so I need somebody to tell me, okay, what do you think will happen? And we know, okay, we have done so many shock towers and so many long members there, we have a feeling for it, but for other things we don't, and that's why this is a discussion process then. And then if there's a risk that we see, we basically handle it with sample parts. So we ask for, let's say, 5-10 parts for the Gigas, not too many. And we define in our specification and in our quotation, we define, okay, we will accept parts up to plus minus 5 millimeters, let's say. And the target tolerance is plus minus 0.5. So we know for each location, okay, what would be the worst case and how much do we need to overbend in this region to achieve the effect that the customer wants. And then we go hands-on and we try it. And if we see any risk or we hear a certain crack, then we need to discuss it.
Mm-hmm.
But usually it's never a serial issue. In the serial production, it's always, if it happens, and it happens in the first analysis, we all actually try to break to see where we have which impact. We need to know about the correlations, the force needed, and the maximum force you can apply for each location.
I think we have to dig into one thing, especially in the for our listeners, is too deep in the technical thing. So you said you have to overbend it, so you overshoot your target. Can you explain for the listeners why do you have to overshoot? Because in earlier said there could be cracks.
We have to overshoot because basically, well, there's a certain working window. So you don't want to reach tensile strength. You don't want to reach the crack, but you need to be above this elastic deformation. We call it a spring back. The part will jump a bit back. Many people also ask me about the holding time, which for us it has an influence, but a very low one. This degree of overbending is much more important. That's the basis for everything we do. We have to learn and to understand how much will the part come back in this location.
Getting into some business, money thinking. I might be a metallurgist, and I like metallurgy, but I love money. I'm claiming together with Fabian that Gigacasting project are the best projects because all of a sudden people are throwing money into those projects. You can actually ask for a straightening unit. You can actually ask for an extra set of tools or whatever because risk mitigation is the key word. Do you agree with this?
Definitely the risk perception has an enormous impact on our machine price. For the rear underbodies, I have so different approaches. I mean, everybody's very secret about the design of the rear underbodies, but 90% look very, very similar to each other, and still the approach is so different of how to handle that. So basically, what's left, if the parts are the same, let's say, what's left is the adversity to the risk. You see. And now we also have a lot of new players. They didn't cast a shock tower yet, but they start with Giga. So there's also sometimes maybe some experience gap. This would be the other factor. But the risk factor is a big one. If you would talk to a Japanese customer again, I think they would per se have more access than, for example, if you go to the US, generally speaking. Not always true. But where risk is a big topic, you end up with a machine that is bigger and has more access because you don't know what could happen. And I want to be safe that if it happens, I can react.
So you overinvest in functionality?
Potentially, yes. But the good thing is,
potentially, yes.
I would rather prefer to overinvest in the first machine and then save on the next ones. And what we do also as an approach to make the life of our customers a bit easier is that we say, okay, now we could have, 28 axes, but maybe we're fine with 26 or even 15. We design them, but we don't build them in. But we have the option later to respond.
You have the channels in the PLC and all that stuff.
Yeah. So everything can be upgraded later.
If it's not needed, you can put it in a spare part package or whatever else. So there are different ways to handle that because the lead time then becomes a topic. So especially for we always use servo linear axis for the straightening, or not always, but for all castings, aluminum castings, we use them. They have a lead time, and you don't want to, aside from building them in on site, that the customer is always more complicated than doing it in our premises. But lead time has been, for the last years, a very critical topic. Then how quickly can you get these units if you need them? Because
how long lead time do you have? Ballpark.
Depends.
Is it a year or? And when do you start to count the lead time? I mean, you have a first discussion, and then you have a PO, and then you have a engineering phase and all that.
You don't know how often I change the wording in the answering to RFQs, because at first I said, okay, from PO 12 months, but then we had a PO and no technical clarification. The next time it was the other way around. So yes, we need to have the concept clear, the measurement plan clear, and the PO, and then I would say roughly 12 months is a good expectation until factory acceptance in our location, so the pre-acceptance, and then it depends on the shipping and all that stuff. Yeah.
In the beginning of this, I saw a PO as a start of business with a new customer. Today, I see it as a start of real discussions about layouts and stuff.
Yes. It and there's so much. How to say it? It was easier before, in the good old days, you had a casting part in front of you, and then you started discussing, and then there was a PO. Now, reality is that we're lucky if we have a drawing or a 3D set already. The problem is also we need the raw part, and that comes after in development usually. And then you think about the concepts. You have to take assumptions with the customers, and then again, that's where the risk aversity kicks in a lot. And you take those assumptions and you agree on a concept. And talking of our latest machines, I've seen pictures now that we are 1 year in the project that the plant is built. So things are definitely changing in that matter.
But what is the biggest risk if you look at the Gigacasting project, not your machine here now, number of channels and all that? What is the biggest risk you would see as or general root cause of risk in the Gigacasting industry?
Good question. Well, right now I see the big risk that people are. If we talk about straightening, I cannot touch on everything else. The logistics are challenging. I think we don't need to discuss on that. For straightening, it's really that there is not much knowledge. There are many different players with different approaches, and nobody really knows the economical impact you can have with these parts. But for sure, if you want, talking of lightweight, if you want the best part with the least weight and the least material, you have many changes in wall thickness, which usually lead to more distortion. And I've been speaking on a congress, and one of the answers or the questions was, what's the most challenging thing with the Gigas? And it was the geometrical tolerance. That was the biggest risk seen by everybody. But still, when you discuss with people, somehow they don't see it as a big risk that something might happen. And the problem is, and I've learned that with some customers the hard way, if you don't have the production space, if you don't have the budget, and then you need to find a solution to deal with those huge parts, because the machines are also huge. Also for us, the footprint that we need is bigger than everything before in this area. So the risk of not considering it and then having to respond is so big in these projects, and it will have the impact because nobody knows, will it be financial success? And then you destroy this potential financial success just by not considering a step in the process that I have to say, I think is necessary.
Yeah, that's an interesting point, especially depending on who you talk to. There are some people around that say, if you design your trim tool right, you don't need straightening because the trim tool does it.
Now you gave me something. I'm sorry.
Please go ahead. I was playing that arrogant person. No, please respond to that.
No, it's absolutely fine. And I love the question. We've had some small battery compartments, battery trays, or our customers had, where they managed to get the deal done with a trimming press. I mean, it's a simple box, and it's relatively okay. The size was okay, and it worked. So I don't want to talk bad about trimming presses. I also like some of those companies. We're good friends. But what they also tell me is that everybody expects them to do the job of straightening, and it's just not possible. And the worst, and that's what I've seen in a battery tray project, you suddenly get another factor that is absolutely not, you're not able to calculate the effect of the trimming press. So when you have, let's say, a battery tray, you usually have the outside walls and you have some structures in the middle on the floor to give it some stability. The normal behavior is you have a sagging part in the middle, maybe from heat treatment, or if it's non-heat treated, but just the material will go down usually. So what we do is we press in one location, bring the floor back. We have a gravity die casting, a battery tray. We need 4 locations to get the flatness of the floor correct. If you do the same in the trimming press, we've received many sample parts, and suddenly you have a plus minus in the part. Then where do you press? You can press in each single location. Then you need 50 axes on, 1 meter or something. But you get an uncontrollable effect, and you have a positive, negative, constantly changing. And then if we push in the positive, we will kick the other values out that are already positive. If we push down, that's the same thing. So this risk is extreme of doing it with the trimming press. And you have a different part each time, each casting. We all know it's different than the next one. Why would you do always the same approach to solve a problem? The answer cannot be working for everything.
That's an interesting question, especially with your explanation now, wouldn't it be better to get a straight part when you use something like a laser cutter instead of a trim press?
I'm not deep enough into this technology, so I cannot answer your question 100%.
But the laser thing is making a lot of dirt. We have tried it.
There might be other effects that I don't see right now, so that's why I cannot do it 100%. But we've seen something very similar, for example, with the extrusions. So we also straighten extrusions, and they are often coming now in an L shape. And if you look at the extrusion process, in the end, they kind of pull out the extrusion from the press. And this stretching, or I only know the German word, recken, if you do the stretching, you destroy the angularity of the L, and also non-reproducible way. So we have now a customer that just skipped the stretching step, and the distortion is worse, but we can handle it much, much better because it's a natural behavior of a part, and then it's easier to correct it. The short waves are always the problem.
Gigacasting projects, they are good for you, right?
Yes,
good
and
budgets, time pressure, new players,
paying
for knowledge, right?
And
Yes,
everybody at the same time.
Everybody. Well, we had the first wave, I think, in 18 or 19. Then it got very quiet, and now it's fully hitting back.
Yeah, but if you look at it, sorry for interrupting, but there's 110 plus contracts on machines 6,000, 9,000, 12,000 tons. I don't know about your experiences, but I have experienced that few of these companies are, as you said earlier, maybe a little bit more based on sheet metal or something else. So they have a little bit of a difficulty to employ enough people to actually work with castings, and they're vacuum cleaning now the industry. So I mean, it's great if you're looking for a nice job, but what will happen when all these 110 or 150 die casting machines are supposed to start to produce all these parts? And will it be people enough for? I mean, come on now, I'm 54, troubleshooting, problems, maintenance, understanding time zones, Mandarin, English, Swinglish, German. I kind of see a problematic area ahead of us.
I tend to agree. So, I mean, the one thing is that in casting industry, I don't know why, but people got rid of all the old experienced people in a field where experience is just so much. That I don't understand this trend, but now it happened. So a lot of these people actually come back. I mean, you see it also in Japan or in other countries. They are retired and they come back into business because the knowledge is just missing. And this will not get better, I think. So yeah, I see a huge risk. The other risk is how much aluminum can be in the world. I mean, I've seen so many OEMs that they have like 10-15% aluminum in the car, and it was already a big success, and they want to go to 100 now. So the aluminum topic itself will be interesting enough with the Gigas. Well, I hope I don't have to talk with my colleagues about 110 Giga straightening machines in 1 year. That will be a tough discussion. Yeah. But there will be shortages in several areas, I guess, of knowledge, of certain machines. It will be tough. Yeah.
What do you think how that will play out? Especially these gigacasting machines are directly connected to the car production line. And just because there's a shortage, you cannot stop the car production because there are not a few thousand people working there and you cannot put them all in the break room.
Well, the good thing is, if we're talking about straightening, so many good people with a hammer did an amazing job in the past. So there might be solutions. Maybe not in the cycle time. That's usually what I see. You need a lot of storage space then. So I visited one customer. They do the shock towers, for example, manually. Just to give a rough example, in automated line, so in our machines, it's around 50 seconds to straighten. Manually, you need 15 minutes. So yes, all these parts have to go somewhere, and that's indeed this hard link. Hard link is always, if you talk about machines, if you talk production process, a hard link is always a risk, and this risk did increase a lot with these new concepts. But still, to answer your initial question, by the way, if it's good for me or not, it will create new business for our company. We will sell less machines in theory, because if you straighten each individual parts, we will have more machines that we need to build. Yeah. So commercially, it might not be that good. Then let's see how the market will develop and how much customers are willing to pay to be the first one with the machine. That might increase the leverage for us again. I'm fascinated by them for technical reasons. Also, when I see our machine now and these new approaches, we had to find new solutions for leveling, because putting something on 3 datums is not possible with this weight anymore. You will have, we call it the wings that go down, and other effects. So we needed to find so many new solutions that from an engineering standpoint, it was amazing. If it's the solution, I don't know. We've also, I mean, you mentioned Martin Hartley. We've read the paper about his thought of impacts of gigas and repairability, logistics. There are so many challenges. I frankly don't know if that is the solution. I think it will be for some cars, for some parts. Then it also depends. I mean, we see in the world market a huge difference in the need for quality. So if a car doesn't have to last 100 years, you can take a Giga and just somehow press it and fix it and then weld it and it might hold. So there are different approaches to deal with these topics.
I think, try another theory that I have. I think one factor that will decide if a car company will be successful with all the gigacastings is the ones that actually produce the cars. I mean, we always speak about if the car line is standing still, it will be chaos, etc., etc. But we have seen that over the years. We have seen some car companies where the waiting list or waiting for a new vehicle, not mentioning any names, could be like 12, 14 months in worst cases because they start to sell a new one. You had 16 months, yeah.
Estimation is 18 to 20. Mm-hmm.
So I mean, if you look at me, for example, I'm not a typical car owner, but when I change a car, I by some different reasons, it has to be pretty fast, and I cannot wait 12 months then. And so I want a car now, like Americans, and if someone promised me a car in 3 weeks, but it doesn't end up there, and they say, 12 weeks, 16 weeks, and now we're at 12 months, sourcing will be a great thing. And sourcing is, sorry for a lot of words here, sourcing is always a big thing because there's cost, logistics, and all that. But if you fail, not sourcing at all, you have a problem. You didn't buy enough aluminum, your tool is worn out, the straightening is not working, something goes down, you were cheap, so you didn't buy an extra 6,000 ton for redundancy. You miss your production spot and you miss to get the car to the car dealer. Yeah. I think this is going to be a factor, not what's written on the hood of the car, actually. Because when people like me, which are guessing quite many, needs a cheap car to go from A to B, then we pick the one that we can afford and we can buy.
Yeah, with one limitation, I think sometimes right now I feel like the safety factor is underestimated in some cases. I did reconsider already my car choice because of this factor. Luckily for them, nobody's able to deliver right now, so it's all the same basically. But yeah, taking this decision then in a different way, and it will have a huge impact if the car is not available, I will not wait. This is also something, because also cars are more like cell phones now. You want to have the latest model, you want to exchange it quickly. There's a change in behavior. And what we have seen is, if we're talking about tolerances and everything, so maybe the German OEMs, they have a very high approach on this Spaltmaß and everything, so they want low tolerances, and maybe that's not 100% necessary, because it doesn't help me if I go into the car and the electronics don't work. The user perception has changed. I don't care how awesome the car looks and how each gap is if I just have to wait for the GPS, if I cannot listen to music, or when I am on a phone call, the whole system is rebooting. These things are just becoming more important to us now. It's a tool. It's not the law for an 8-cylinder or a Porsche Boxer or whatever. It's much more an everyday tool. And then quality and the logo might not be the main factor. Anyhow, as we see that design gets closer to each other. Yeah.
Also, that's something we had in the earlier podcast that we discussed, that it's more like our cell phones are so well integrated in our everyday life. We want to have the same experience with a car. Yeah. And if that doesn't align, that's terrible. We see it in many, especially German cars, when you sit in there and you put in Android Auto, then it's on the separate screen. You cannot have the map on your head-up display because it's running Android Auto. And all of these small things really get annoying.
It starts a bit earlier. So the car I still have now, because the new one is not coming, I cannot use Android without the cable. That's the very first step. So just to connect these systems, somehow, I think it was possible. I was once visiting a holiday in Italy and I had a small Fiat rental car. And it was possible to get into the car, have Android working, no cables, nothing needed. And then I come in a triple budget car and I first have to search for the cable, and then they changed from USB-A to USB-C for the main connection and stuff like that. And it's getting really uncomfortable. And every time that I put the rear drive in and the camera is not starting because for some weird reason it needs a minute to boot up first, I'm freaking out. Sorry.
Yes.
I want things to work.
Here.
I still want them to be reliable. But I think this minimum level is given almost anywhere.
My 19-year-old kid, he's driving a lot of car, by the way, because he's going back and forth to school. So he's making almost 100 kilometers a day through Stockholm, right? And he had his driver's license for what is it now, 1 year and a half soon to be. And hearing this 19-year-old iPhone generation talk about our cars and his annoyment, and he would sign what you just said about this with, it has to reboot before the camera goes on. And it is just apparent that the new generation, they don't accept it. We, the older guys, we stand it because we feel like, electronics, there's something magic happening here. I sit down, I take a snooze, I drink some coffee. That's okay. But this iPhone generation, they go like, shit car, directly. 15 seconds in, they say, this is not a good car. And I mean, this is actually a European car with quite high price tag.
Yeah.
That's interesting. So he, just to finalize this, because he claims I need to buy a new car because this one doesn't work because the infotainment system is 45 seconds in the drive, right? So he's building a lot of cars, and now he found some groups on the internet that are rating reliability, or how safe are you to go from A to B with all the functionality. There are nerds doing that, and guess what? Where European cars are, not top 5.
I give you my top 1 example, and then I also close from my side. I had my GPS running, and now everybody, the easy thing is to put screens everywhere. So the cool thing is you have a head-up display, you have a digital cockpit, you have a console where you have the GPS, and I had it on, funny thing, on all 3 of them, but not with the same routing. and I thought, okay, maybe I just drive into a tree in the middle, or I don't know what I should do, because I was really like, okay, this cannot be, it cannot happen. I thought they used the same ECU, but then again, electrics for me, it's also magic. But things like that, when you're driving on the highway with, 160 or better, they also become a safety risk. Another one, because you're suddenly like, what should I do?
And you start to fool around with your fingers and trying to point on something to correct it, right? In 160 kilometers an hour.
The one thing, why do climate controls and things like that work on a touchscreen? I don't get it. I mistype every time when I'm trying to get the phone book. I mistype several times because there's a bump in the road, and the infrastructure is also not becoming better. And sometimes I just don't know why we're so keen on those touchscreens, or make the buttons bigger. I don't know, but there are other factors. But yeah, I think like we are especially losing the thing here, and you've seen it with the success of some Chinese European players or whatever else that suddenly become. I think MG went way over the ID in the beginning, and things like that happen because of this. And now I had the fun of driving one of these new cars, and it was terrible if I go for the chassis and how weak this car was on the Autobahn with higher speeds. It was really, I didn't feel good or safe, but I never had a cell phone issue, at least in this one.
No, it is worked.
So is there a different standard of what is a quality car now? That's the question. Is it just piece something together and call it a car as long as the infotainment system works?
Yeah, I think there are some players following this approach, and I don't appreciate it, also for professional reasons, because I want to sell our machines. But yes, there needs to be a debate on that, I think, also.
In Sweden, Teslas are super popular because in Sweden we're so trend sensitive, so everything that's new and not Swedish we import directly, like pizzeria, sushi bars, Teslas, jeans from the US and so forth. Anyway, now, but it was so funny that one of the first groups that emerged on Facebook was actually, it was called like this, if I translated, not a single sheet metal part is straight. That was the first generation of Tesla. So if you look the gap, with the door and the frame, it was like 5 millimeters up here and 2 millimeters in the end. And they were hilarious how much jokes they were making in this group. But then Tesla,
but still it sells.
Still it sells because the infotainment system is brilliant, right? You can have reindeers running.
Also, for me as a Tesla driver, I really picked the car because it once had a Gigacasting in the back. For me as a casting nerd, it has to be. And the other thing is charging infrastructure and the infotainment system.
But it's a good car, Fabian. You have a good car.
It definitely is a good car. I love it.
Yeah. My problem is the car I want to have, the Volvo XC90, the variant with a battery, it's 3 tons. 3,000 kilos. Imagine going hunting, a little bit mushy grounds, and you stop there, you're a little bit stressed, out with the dogs, out with the guns, into the wood, coming back after 5 hours. Will it be standing on the wheels or on the ground? Will it sink? I mean, it's 3 tons, right?
But there is the new shaking method that Mercedes developed for his G-Class, and you can also apply it on the street corner at the red light.
At least there's a cool engineering solution probably to solve that thing again. But I understand that part. I'm not a fan of SUVs. I lost everything, I think, anyways, any discussion here in the city. I mean, the charging infrastructure is good here. So if I look around my house, I have at least 6 fast chargers. And I think there's a lot that changes. And this will also make some other arguments against Tesla or against electric cars. They will fade, maybe.
There's one thing that all the others don't have: automatic routing through the chargers, because that's really the big thing. I just type in where I want to go. I don't have to care about any charging stop. The car tells me go there. And if you want to go back, charge also here and for that long. And for the others, you also have to do the planning manually, that you know for which network I'm in and which chargers are on the way.
Yeah. I mean, you can make jokes about electrical cars and stuff, but I'm the old guy geezer in this team, right? I mean, we all heard that going downhill is just for the rich people. Now everybody's doing it, or you can have ice cupboards instead of fridges for your food in the 18th century and all that. But believe it will just fall through because there are some good reasons. But one thing, oil is not eternal. I mean, you have reached oil peak consumption in many countries already. So oil is drying up, and the oil we have left, we need to do plastic things to give away on McDonald's, right? So we have to do something. And I mean, what are the alternatives? The best thing for the environment: run some nuclear power plants and charge your car. End of story. So we will be there. And even if I like the sound of a V8 or a V6, okay.
Yes, but so not for every day, and that's, I think, the thing that changes. Even if I love a Porsche or a V8 or whatever else, do I want this every day? I mean, it makes it so special that you don't have it every day. So I love these moments when I actually have the chance, and I still want to keep them somewhere, so they should be in this world, hopefully. But it's not an everyday device necessarily, and I think that's the thing that changes. We need to, as you say, we have a lot of struggles. I did not decide on an electric car yet because my user profile just didn't fit so far. My office is 400 kilometers away. And as I said, the customers are in more distance, so it becomes very complicated. And I decided to wait. I thought about a hybrid. That's probably an option, but then it's not really the full thing as well. So then I'm somehow
but it
more
goes
interested.
a long way, you know. I got a hybrid, and many of the travels I do is actually very short travels around the home, grocery shopping and all that, and then you actually go on battery.
Yeah, for this it would be, but then you get into different like backdoor issues. Right now, for example, I have a wall charger in my garage, but doing the company car there and then sending my company a bill, there are so many small processes that are also not really solved yet. And I honestly, I didn't like the range, because nobody could in Germany, at least. I think most of the cars couldn't guarantee these 60 kilometers. If we go for 100 kilometers, I think I'll be totally fine. Then I can do most of my everyday life, and then for the long distances, you could have the gasoline engine. Or another principle, that's also the thing: does it need to be battery electric or not? So there are still some questions. I think I don't need the V8 sound every day, to be very honest. Although that gives me already a lot of criticism in the car and casting nerds, but I don't need it every day. I like it nevertheless.
I have a different perspective, but it goes. I think the result is the same. I've heard every 5 years that I need to change my car. First, we have gasoline cars, and then we're supposed to have ethanol instead in Sweden. So everybody was buying ethanol cars for 5 years, and then that crisis came, and we were supposed to have environmental friendly diesel with the catalysts and stuff, and then we were running that for 5 years with low taxes, and then we were supposed to have hybrids all of a sudden. So Toyota the Toyota lobby must have been fantastic towards the government, because all of a sudden everybody was running a Toyota Prius that couldn't climb a hill if it was too steep. So every 5 years, someone is trying to teach me to change my car to have another fuel system. And this time I felt like secondhand market, lithium-ion battery why not sit tight for another 5 years? Because then some smart boy or girl will invest and start to produce solid state battery that will take me 1,000 kilometers in one charge, and then I'll buy.
Yeah.
Because it's
No,
going
true.
so fast, right?
Yeah, development is huge.
It is.
And the
It
jumps
is.
we see in development right now. Yeah, definitely. So I'm waiting. With 1,000 kilometers, you could also get me. I'm not attached that much to the gasoline engine. And the good thing is they all have structural castings. So I mean, what are we talking of? There will be some straightening in, and then I can drive everything all fine.
Oh, that's perfect. And I do have also one last question. All these Giga projects, do you love working on them?
Yes, I do. Absolutely. But I also love many other parts. So that there are, one example, we had a first long member that was so thin-walled when touching it with the measurement probe, we already changed the part. So there are so many crazy developments that no matter which category of parts, and also to watch this alloy discussion, I'm not the biggest fan of these new alloys because I feel like we force aluminum in a state where it doesn't want to be, and I'm just questioning if that's a good thing. But there are definitely advantages to it. But well, also for business reasons, I still like heat treating. But there are so many different interesting developments. The good thing is, and that's the one thing I give Elon Musk, or yes, maybe not the invention of this technology, but for the making it a marketing thing. We have huge chances. We have now casting being a topic in the media with people where casting was never interesting. And suddenly with Tesla, we see that people are interested in casting and gigas. And I can talk with people that never spoke to me before. All this stuff, I find it fascinating. And making maybe the casting industry a marketing thing is the biggest approach or the biggest change that I see and that I like a lot. Even though I don't like many other things in this perspective, I also don't know if Giga is really the best thing. But to bring this in the public discussion, to have these discussions about casting, about technology, it was a more than necessary change. Also for getting young people, attracting. We talked about not having any labor in future or not no workforce. Sometimes I wonder why casting industry, as much as I love it, why are they always advertising with flames and dangers and metals pouring around? And I'm not sure this is how you attract the latest generation of engineers or other people that come into the labor market now. There is a change in thinking. We had it with the perceived quality and other factors. And the same goes for the working environment. So change was more than necessary and more than needed. And I don't agree to everything that is changed necessarily because, there are also some bad changes in this world. But that's a very interesting one. And I love working in this industry and loving to see these parts, to create something that's still the best thing in life.
That is an amazing last sentence, I would say.
The philosoph came down in the end, yeah. Thank you.
Yeah, always end on the high note. So thank you for being with us, to talking about that openly, about the issue of straightening the castings.
Thank you very much for having me. Yeah. I would have loved to be in the production line and to show you some machines. Unfortunately, as we discussed before, I couldn't travel today. So maybe next time I can show you around and we discuss something moving. That's more impressive.
Looking forward to it. Yeah, sounds like a plan. So thank you very much, Philipp, and see you around, I guess, as we are in the same field, all three of us. And it's a small community. It's a small village.
We've seen each other before without knowing, and we will see each other again with knowing now. So that's cool.
Looking forward to it. Thank you very much.
Perfect. Thank you for listening. Don't forget to subscribe. And we see us in the next one. Goodbye.
All the best. Goodbye. Bye.